We will now see the digital reconstruction of a blastoid calyx and one hydrospire set. Here we have in the distance the blastoid calyx, which has been transformed from the digital images into a three-dimensional model through a series of outlines stacked digitally one upon the other. It is a simplified model. However, spiracles and ambulacra can be distinguished in the relief. The digital model can be reunited with the photos in order to view the object as a solid. The calyx can also be made transparent to view other reconstructed isolated parts, such as hydrospires, as shown here in yellow. The calyx can be rotated in any direction in order to better visualize how the hydrospire set is oriented in the calyx itself. The hydrospire can also be viewed in isolation, revealing a V-shaped structure with serial rows of pores along the legs of the V, sticking out like spines. Duct columns run the length of the legs of the V, which make a bend and connect to form the spiracle at the apex. The isolated hydrospire can be united with the calyx and also the digital images of the original photos, which better illustrate how other hydrospire groups connect to the reconstructed set. One can see that there is a deltoid plate that lies directly overhead the hydrospire set. There are several anomalous pores projecting out at different angles to the pore rows. Two near the spiracle lead into the coelomic cavity, but others lead into the calyx wall itself and end abruptly. The transparency and opacity of the calyx demonstrate the versatility of the visualization techniques used in this study. Any structures captured in the digital images can be outlined, isolated, and reconstructed, from the hydrospire to skeletal plates or even the diagenetic crystalline alterations. So the ability to reconstruct features poorly understood because of their position inside matrix or fossils themselves can be approached in this way.